right, class, I'm going to read to you problem 50. It says, there's an antenna on the top of a building from a location 300 feet from the bottom of the building. The angle of elevation to the top, so here's my building. So from this location, the angle of elevation to the top of the building is 40 degrees. And sure enough, we hope that building's perpendicular to the ground. From the same location, the angle of elevation to the top of the antenna, and here's your antenna, and it could be further in, but since you're far away, you see the whole thing. This is 43 degrees. Okay. All right. Find the height of the antenna. Okay. So this height here of the antenna is definitely not part of a right triangle. So if you look at just this height, this is not a right triangle. So we can't go straight for that. But what I will definitely say is that this height can be looked at this whole side y all the way down to the bottom minus the height of the building, call that an x, right? So I'm going to say that h is equal to y minus x. And both y and x are part of right triangles. So let's start with x. Here's my right triangle. What do I know? I know this side of 300 and the angle of 40. So what would put this side, the side x, and the angle 40 together? Sure enough, of tangent. Tangent of 40 degrees is opposite over adjacent. Opposite over adjacent. So sure enough, x is 300 times tangent of 40 degrees. This big y, part of this triangle, I have an angle of 43 degrees this time, which is the opposite y over the adjacent, which is still 300, yes? So from here, clearly y is going to equal to 300 times tangent of 43 degrees. Take both of these out, subtract them, and you got your h. So h is going to equal to that 300 times tangent of 43 minus 300 times tangent of 40, which again, you can put the whole thing in your calculator at once. This, by the way, I have it at about 279.75, and this I have it at about 251.73. So when you minus them, that's about 28 feet. And again, 0.02, that's fine. Or you can put the whole thing in your calculator, type it all, press enter once, and you got even a more accurate answer. Okay. Let me pick another problem out of your textbook, and I'm going to pick problem 43 that simply gives us a picture. So this side is 85. This is the right angle. This side's 50, or this angle is 50. This angle is 36. And we want this whole side of x. And again, same thing. That whole side of x does not come out of a right triangle, right? So how are we going to piece together the x? Maybe out of this part here plus this part here, right? So x, I'm going to say, is made up of these two pieces, each of which come out of a right triangle. Okay, so let's look at this triangle here. What do I know? I know that's 36 degrees. I know the opposite side, and I need this adjacent side. So sure enough, that's a tangent. So tangent of 36 degrees is the opposite over the adjacent, yes? So again, I'm just looking at this right triangle. So solving this for x1, is simply 85 divided by tangent of 36 degrees. What do I find for x2? I'm looking at this triangle right here again. Angle, opposite side, adjacent side. That's again a tangent. The 50 degrees is opposite over adjacent. So x2 again will be 85 over tangent of 50. What do I want to do with these two values? Add them up. Right? So same thing, you can put the whole thing in your calculator. Be sure to use nice parentheses to make sure that the order of operation is used correctly. I actually didn't even put this answer in my calculator, but you'll come up with something. I don't have a calculator right here. Okay, so there's that, you guys. Here, I can try a couple more problems out of a different book just to give you a little bit more practice, but I know you've done these in your trick classes, so let's see. Here it is, another one about angle of elevation. So since these don't come out of your book, I'll write them down. So an angle of elevation of the sun is 63.4 degrees when a building casts a shadow of 37.5 feet. Find the height of the building. Okay. So what am I going to do? Well, draw a building. And somewhere up in the sky is the sun, and it doesn't really matter on what side you're putting the sun on. What's going to happen? This sun is going to cast a shadow of the building on the ground, yes? Okay, so same thing. The building is perpendicular to the ground. It says what? The angle of elevation of the sun is 63.4 degrees when a building casts a shadow of 37.5 feet. So which one's the angle of elevation of the sun? Always, always the one made with a horizontal, not this one up here that's made with a vertical line, always from the horizontal up. So this angle is 63.4 degrees. So we want to find what? The height of the building. So one more time, what's going to put this angle, this side, and this side together? Well, that's a tangent. So tangent of 63.4 degrees is simply the opposite over adjacent. So the picture is everything. Once you have the picture and you have it all nicely labeled, it's super easy to figure out which trig function you're going to be using. Right? And again, put this in your calculator and you're going to come up with some kind of an answer. And here it is, maybe just one last question. So it says, we'll come up to, also in trig you've done a lot of south, north, bearing problems. So we'll leave these for chapter 8, by the way, when we will be able to solve non-right triangles. That's much easier. So it says, to estimate the height of a tree, a person position himself south of the tree. So to estimate the height a person positions himself south of the tree. So here's my tree. So south of the tree, and then another person is east of the tree. Okay? If the two people are the same distance from the tree, and 35 feet from each other, what is the height of the tree if the angle of elevation from the ground at each person's position to the top of the tree is 48 degrees? Okay. So, and again, I drew this thing goes exactly perpendicular here, right? You're not really going to see it, but you have this angle all the way to the top here, and you have this angle all the way to the top here. I just drew this picture. I just made it flat. But the tree stands up, right? And again, it's this triangle here and it's this triangle here. I just can't make it 3D picture on a 2D plane. I'm just not that good. Okay, so the point is it's pretty easy. This is a side x, this is a side x, this is a side of 35 feet. Do you think we could find x out of this? Sure enough, x squared plus x squared is 35 squared, right? First of all, right? So out of this, I can find x. By the way, I can take the square root on both sides. So x is 35 divided by the square root of 2, or 35 square root of 2 over 2 if you want it. Okay? Then I have the side x. Now how could I find the height of this tree? No problem. I know this angle is 48 degrees. So one more time. In this triangle, what's going to put together this angle? The adjacent side and the opposite side. It's definitely, again, a tangent, right? So tangent of 48 degrees is the opposite, which is the height of the tree, over the adjacent, which is x. So h, one more time, is going to equal to x, which is 35 divided by the square root of 2, times tangent of 48 degrees. Whatever number, again, this comes up to be. Okay. So I just wanted to pick some problems that honestly I haven't even looked at before, because I just wanted to show you what am I seeing when I read anything. Yes, I see a building, I draw a building, right? I hear about a sun, well, it's up in the sky, right? It casts a shadow. Boom, where's the shadow? On the ground. What's an angle of elevation, right? It's an angle made with the horizontal. Label it. Once you have the picture, you're good to go. Same thing. Here's a tree. We're starting with that. I drew a tree. Yes, I have a person that's south of the tree and a person that's east of the tree. So, okay, well, there you go, from the base of the tree. Yes. And then what? It says they're the same distance. Well, immediately, what did I do? Put x's on both sides. Yes, that means it's the same distance. And they have 35 feet between the two of them. So clearly out of this, I can solve for x out of Pythagoras' theorem, right? So luckily it's the same, right? Okay, then what? The angle of elevation to the top of the building, yes, so from the horizontal up. It's just that I projected it on a paper, right? Two-dimensional paper. And then that's the 48-degree angle. So I'm using this triangle to find x, and then I'm using this x further in the second triangle to find h. The part about what this actually comes out of the calculator is a little bit insignificant. You can put that in your calculator yourself. Okay, so this concludes chapter 5. I know you've done plenty of these problems as well in your trig classes. As you definitely see, none of it is new. I've taught trig many times. This is actually out of the trig book, these problems I took. So is really nothing new, right? Draw a picture. That's also not new. You just need a picture. Once you have the picture, you're good to go. Okay, this is it.